Well, welcome back to part 3 of our unit on chemical and physical changes. And this particular lesson, I want to focus on two terms that are very similar, that actually are kind of opposite. So by the time you're done, I want you to be able to know and recognize the difference when you see these. So the terms are in front of you there, endothermic and exothermic. All right. So I'm going to kind of make a chart here where on the left side I'll describe what endothermic means, and on the right side I'll describe what exothermic means, and then we can kind of contrast them as you look side by side. Okay, so I'm going to start with just really what makes these different in the terms. So you can see endo and exo. Okay, and if you want to think in your mind that's the difference between like enter and exit, that's not a bad way to start. So just the roots of those prefixes kind of tell you a little something. So thermic, we're talking about heat energy, okay, or thermal energy, sometimes it's called in science. And so in an endothermic process, we usually say that heat is taken in. Okay, the key word there is in. And with an exothermic process, heat is given off. Or you might also say it's released. Okay, so it exits the system. If we could draw a little diagram. So we're usually talking about, for example, a chemical reaction. Typically they're either endothermic or exothermic. So if you can imagine this chemical reaction happening in a little container, like in the science lab we would do it in a little glass beaker. So that beaker would just look like this. And if this particular reaction is one that requires heat to come from somewhere and go into the container for these things to be able to react, then it's endo. But if, on the other hand, the container releases the heat, then we would call it exothermic. Okay, so there's just a little like picture format of the difference. All right. Often in an endothermic reaction, because we have to put heat into it from somewhere. So where's that going to come from? It could come from a flame or a stove. So a lot of processes in your kitchen are endothermic processes. An oven, something like that. But it could also be like the sun. I mean, the sun can provide the heat energy that allows some processes to happen. All right. And a lot of times with an exothermic reaction, the heat can be used to warm things. Okay, such as your house, for example. When you burn the natural gas, most of you have natural gas furnaces in your home, and that's how you heat your home in the winter. That process of burning that natural gas is an exothermic process. So we take that heat that's released, we use it to warm up the air that passes through the ventilation system in your house, and that's how you warm your house. Okay. A lot of times students get confused because we talk about heat going into a system, and they tend to think then that the system will become hotter. But that's a little bit of a misunderstanding. Although in the internet you'll find a lot of confusion about that as well, people who think they know what's going on. But usually that heat energy goes in there and it is used to do something. For example, to break apart some chemical bonds. It doesn't stay as heat energy. It turns into other forms of energy. Okay? So what actually happens is if that heat comes from the surroundings, then they will feel colder. The surroundings, that is. So that's often like your hand. So if you were holding this container, and just look at this picture up here. So in order for that process to happen, we need to have some heat come from somewhere to go into the container for that reaction to occur. Well, if you're holding the container, it will take heat from your hand. And if it takes heat from your hand will feel colder, okay? So the temperature will drop, not rise, but drop, okay? And again, this gets a little confusing because you tend to think if you're putting heat into something that it must be getting hotter. And if you have it on the stove, of course, and you take heat in, it may be raising temperature. But if you didn't have the stove or flame or anything like that, and you were just letting the environment, the air or your hand or something like that, provide the heat for you, then it's going to make everything around that container feel colder, so the temperature will go down, okay? And here, if the heat is released into the surroundings, okay, this is just, again, maybe the air around the container, or maybe your hand is holding it, it will feel hotter, or the temperature will rise. Okay? So, again, don't get that backwards. Endothermic. Heat is taken in from somewhere, and that somewhere will always end up feeling colder when it gives off its heat, or gives away its heat. And then when the heat is released into the surroundings, that will always make the surroundings feel warmer. So let's talk about a couple examples. Some of these you may know, some of them you may not. But just so we can have a little frame of reference. So some endothermic processes you might be familiar with. Here's one. Evaporation. With evaporation, water is the easiest example. If you have a little puddle of water on your countertop in your kitchen, you come back later in the day, that puddle of water is gone because it has evaporated. What has to happen for evaporation to occur is those water molecules that are sitting on the countertop have to acquire some energy from the surroundings in order to get energetic enough that they can fly away into the air around them. Then you can't see it anymore because they're so tiny. But that process of absorbing energy to be able to turn into a vapor is an endothermic process. So if you could feel the countertop when the evaporation was all done, you would notice that it has a little less energy. It feels colder than what it was. Okay. Another one, and we mentioned this, I got a spare line here, sorry about that, in the last lesson, but photosynthesis, oh, I'm spelling it wrong. Photosynthesis requires energy from the sun in order for the carbon dioxide in the water to form into glucose, okay? That energy from the sun goes into the process, all right? Doesn't mean that the stuff gets hotter, all right? It uses that energy to break bonds and reform bonds, but it's still considered an endothermic process. Some examples for exothermic, the most common example would be combustion, burning. Okay, now again, here this can be a little confusing. You say, well, how do I get something to burn? Don't I have to like light it on fire or put some flame under it? Yes, it's true. Typically, to get the reaction started, you need a little bit of what we call activation energy, a little bit of energy just to get it going. But then you can stand back. For example, I like to light a fire in our fireplace in the wintertime. I just have to have a little flame to get those logs started, and then I can stay back and watch. And as they burn, they are giving off a lot of energy to the air in our living room surrounding, and that's why it's an exothermic process, okay? Any kind of combustion is considered an exothermic process. And how about this one, the opposite of evaporation? When we condense something, so that's a vapor turning back into a liquid, right? That vapor, the particles are very energetic, in order for them to condense into a liquid, they give off a lot of that energy. That energy goes into the surroundings, right? So that's why we call it an exothermic process, okay? All right, so I think that's enough out of paper, as you can tell there. So that's as far as I'll go here. So just make sure you have these down, then I'll give you some practice where I'll describe some things or show you some symbolic things and see if you can identify whether it's exothermic or endothermic. And in our next lesson, we're going to use these terms to describe the changes of state. We have these 6 important changes of state. So solid, liquid, and gas, the states of matter, when we change back and forth between them, it's either an endothermic or exothermic process. So if we get these concepts down now, it'll make that a little bit easier for you. Okay, that's it for now. Thanks for watching.